The oldest one in college had a word problem and got it all wrong. My mom had to make me sit down and go over it with him.
Modeling with functions.
Oh, I needed that.
So, just going to start out with some like information. So, functions from formulas.
Sorry. Can I have popcorn? I'll eat this one.
So, for example, if you were told to write the area of a circle as a function of, what just happened? First, radius r. Well, we always write area of a circle as a function of radius because our formula is a equals pi r squared. But what if instead they asked us to do it as a function of diameter d? How does d relate to r?
It's 2 times it, so you can do A equals pi r d over 2 squared.
Yep. So a equals pi times d over 2 squared, which would ultimately give us pi over 4 d squared. What about if it said that they wanted you to write it as a function of circumference c?
Circumference
So what's the formula for circumference?
is 2 pi r.
Yep, 2 pi r.
Or
So in the area formula, the only thing that like overlaps here would be an r. So I need to get r by itself. How would I do that?
divide both sides by 2 pi.
Yep, so c over 2 pi is equal to r. So now, in the area formula, I'm going to replace r with c over 2 pi. So I'm going to end up with a equals pi times c over 2 pi squared, which is going to end up giving me c squared, well, let me do this, pi times c squared over 4 pi squared, which then reduces to c squared over 4 pi. So that would be area as a function of circumference. So this is 3 different ways to find area depending on what information we are given. We could also have a max value problem. So if they told you a square of side x inches is cut out of each corner of an 8-inch by 15-inch piece of cardboard, and the sides are folded up to form an open top box.
What do you have? Like infinite volume because it's not closed.
Not in the box itself.
Oh.
More like, I mean, I guess you could maybe argue that, but even though there's not like a top closing it, there's still a top of the box, like at the edges. It's gonna be. All right, so I'm gonna draw the pictures here, and then I'll give you what the questions are that go with this problem. So basically, I've got a piece of cardboard. I know that it's 15 inches by 8 inches. They tell me they cut out a square from each corner. And it's X inches, so I'm going to put an X on each of the outer edges of the corners there. And it's going to be folded, the sides are going to be folded up, so I'm going to put dots where it would be folded. So it's going to look something like that when I'm done. This is like if I turned the box over sideways, because this would be where the top would be. Okay. Well, in my picture, because it just, yeah, anyways. All right. So what do I know is going to actually be true about the length of these sides here?
They're minus 2x.
Yep, so 15 minus 2x. And what about this one?
8 minus 2x.
Yep, 8 minus 2x. Because that's got to be the actual side of the box since I'm cutting out an x from each corner. All right, so part A. Write the volume of a box as a function of x. So in general, what is the formula for volume of a box?
X cubed. Length times
Okay, a rectangular box.
length times width times height.
Yep. Length times width times height, so just area with height added into it or multiplied by it. So my length is 15 minus 2x. My width is 8 minus 2x. And my height is what? X.
Superfoil.
You can, but you don't have to. This is a sufficient formula for this because part B says find the max volume. Now, the beauty of this is we get to use our calculators to do this part. Calculator does this for you. So what you're going to do is you're going to take this equation for volume and plug it into your y equals. If you have a stat plot on from anything that you've done on your calculator, somebody's borrowed your calculator, then you're going to want to clear that or turn that off.
Yep. Yeah. So wait.
So we're plugging in this formula, so make sure you use the parentheses. So 15 minus 2x times 8 minus 2x times x. And then you'll do zoom 6 for zoom standard.
You said step plot off, right?
Of course.
Yes. Okay, so you probably can't see the entire graph in Zoom 6, right? I can see like part of it, but not all of it. So what I would say is to do something like a Zoom Fit, which is Zoom 0, and it's going to change it so that I can see, well, at least more of the graph. So this is a cubic function. So it goes up, it dips a little bit, and then it keeps going up. Well, I want to find the max volume. So I'm going to hit second trace. I'm going to go to max, so that's option 4. And I need to go to the left here, somewhere down over here. Hit enter, and then we're going to go over. I need to get on the right of the y-axis. Very well. There we go. So somewhere over here, hit enter again, and then hit guess. So this is telling me that my max volume is 90.7, it's in inches, right? Yeah, inches cubed. Okay, so the y value is your volume. Now, don't clear this yet, leave that there.
I didn't get this thing.
I'm so confused.
Yeah, I did.
How can it be a max?
Oh wait, no.
It's in the middle.
Are you looking at the x value or the y value?
My x
Wow.
value is.
Both of them are different.
Then you probably didn't arrow over far enough to get it then. Or something's not typed in right.
What was the y value again?
90.7.
I definitely did something wrong. My x value is.
Wait, may you
90.
show us again?
Alright, second trace, maximum. You need to arrow over to the left, somewhere over here where you can see it.
Yeah.
Over here, hit enter. Arrow to the right until it gets way over here on this side. Hit enter. Hit enter again.
It just stays on the same thing.
Oh. Is your stat plot on or?
It's up.
Mine's tweeting out too. I put 33 million from Alpha. What did I get? 96. Can you do mine?
Zach, what?
What did you do
What
different?
is your graph looking like?
I followed it and I watched the numbers as I was tracing it because you were going over so far that it was finding the second max.
Oh.
But the second max doesn't make sense because it's a value that's so large that it can't even be, it's longer than the width of the box.
Yeah, because it's two negative numbers that are multiple.
What? Two negatives and a positive.
Yeah. If you have a ridiculous number like 80,000 and 15 minus 2 times 80,000 is a negative number.
Like, I'll put Zach's up here for a second. Alright, so it's gonna be kind of hard to read these numbers down here, but my x value can't exceed the values that I can go outside of here. I don't know how to make this like not look weird on here.
Right.
Like, it can't exceed. So, like, I can't have a huge x value, right? Because it's not going to work. And I also need a positive x value. So, but you can still go, like, over to the left somewhere over here and then arrow it over. So, I'm watching what's happening to the y values. So, my y values are basically decreasing here. And then they start increasing. Then it decreases again. And so, I'm going over somewhere in this range here. And hitting it. Are you in Zoom Fit? No, I don't know what's happening. I'm gonna try something on y'all's. Y'all's may work because if you have an order calculator, it might be different. It might be better. So mine doesn't look like this when I did it. Y'all's may actually be able to say in standard and work. It'd be better. Okay, so if you have a newer calculator, you could have left yours in standard. If you have an older calculator like mine, you're going to have to do Zoom Fit to see it. Because this is allowing you to see it goes up, comes down, and then goes back up. So the max is up here where it goes up and turns around. So I did one on the left, one on the right, and then it gives me the value that I'm looking for. Did everybody else get it?
Yes, ma'am.
Or you have it now if you didn't. Okay.
Okay, yeah, I got it.
I've never had somebody that it didn't work for before. That's why I was very confused on what was going on. Okay, so with that still on your screen, part C then says what side length should the squares have that are cut out? So when it tells you what your max volume is, it also gives you an x value that is 1.6 repeating. Or well, I guess at some point it's not repeating anymore. But so I would just say something like 1.67 inches.
Where did you get that?
The x value.
How does graph figure out the area of the box?
Because it's an equation that solves it for you. Okay. Write a mathematical expression for the quantity described verbally. So number 2, a number x increased by 5 and then tripled. So I'm trying to write an equation that meets this criteria. So a number x increased by 5, what does that imply? X plus 5. And then it says then tripled. What does that mean? Take everything and multiply it by 3.
Wait, why wouldn't it be cubed?
Because it's tripled. Tripled means 3 times something.
To the power of is cubes. But x plus 5 3 times is x cubed.
Well, what's this?
2 plus 2 times 2 times 2.
Which is
2 cubed.
8. What's this?
6. Okay, so how would they word it when they wanted us to put it to an exponent? Would it just
There
say,
aren't any like that, I don't think, but they would tell you it's like cubed or squared or something
Okay.
like that.
You're asking so politely.
All right, 4. 4 more than 5% of a number x.
We do
So x times 0.5 plus 4 is 0.
0.05. So remember percents we do, this would be 0.05. So it'd be 0.05 times x, and then 4 more than that would be plus 4.
That is correct.
Will we have to find out the number of x?
Not in these problems.
Right.
6. The area of a triangle whose altitude, what does that mean?
Height.
Yep.
Height.
Is 2 more than the base length x. So what's the formula for area of a triangle, first of all?
Base times height.
1/2 base times height. Okay, so based on what they tell us, any ideas?
So, same thing, just h plus 2.
The
So-
altitude.
Well, they said base length x. So that means base is x.
Oh, the
So right now 1/2 x, and then
Parentheses,
h is, an altitude is 2 more than the base length
h
x.
plus 2.
X. X plus 2.
Oh, 2 more.
Oh, 2 more, yeah.
So you can leave it like that. If you want to multiply this through and get that, that would also be fine, but this would technically be the formula, so you can leave it here. 8. Income after a 3% drop in the current income of X dollars. This one's going to require a little more thinking to do this one.
This is not just x times 0.03.
It's divided
It's
by
0.97.
Why?
Because this is a stats problem.
So income after a 3% drop in the current income, then that means what we're getting paid in our income is 97% of the income currently. So
The SAT has a lot of questions.
0.97 times x would be the equation for that.
It's like it's
So you got to watch the wording of what they're asking you for so that you know. This is the only one that's really tricky like that in the book. But we're going to stop there
Yay.
because we don't have time. Well, we could probably get through one more, but
I got time this week.
we'll save our last few problems for tomorrow.
What is your
So, and then that way there's no homework.